Hello, algebra students. Welcome to virtual GED class. We're on lesson 4 of Algebra Essentials, and we're going to talk about something so cool, the GED Formula Sheet. I'm not alone today. I have one of my favorite all-time students. Mason's here for you to make sure the kind of questions you would ask get answered. Let's start with just what is a formula. A formula is an equation that describes a relationship between variables that is always true. It's an equation, right? So we're going to have an equal sign. And notice that I say between variables with an S on it. We're going to see more than one letter. And I say it's always true, meaning it describes a rule. This is how the world works. Great example is to find the area of a rectangle. So think of your bedroom. You would take the length of your bedroom and you would multiply by the width, and that would give you the square footage, right? If your bedroom was 11 feet long and 10 feet wide, you could multiply those together and say, oh, my bedroom is 110 square feet. This is the official GED testing service formula sheet that you will get while you take your math test. And there's 3 big sections. The first whole half of it is all these geometry measurement formulas. Area, perimeter, volume, surface area, working with shapes or 3D solids. Boom, that's where you're going to hit up. This second section in the middle, it says data. That's the data analysis section. This subject comes up in math and science, and all they have there is mean and median. And then the bottom says algebra, and it's weird that it just says algebra because there's all kinds of stuff in there. But if you have some random thing that's not geometry and not data analysis, let's just hit up the bottom and see if they have it here. Let's look at the sections a little more closely. So I want to look at that geometry section. It is broken up into 2 basic categories. We have the area and perimeter formulas, both ways to measure 2D shapes. So your flat shapes like circle, square, rectangle. Perimeter goes around a 2D shape, and area covers a 2D shape. And it doesn't just cover it, it covers it with squares. Like we were talking about the square footage in your room. You could make little squares out of the 1-foot measurements by just dropping those lines both directions and measure how many squares it would take to cover the floor of your room. The perimeter, on the other hand, like for example, if you took a walk around the block, perimeter, you would go around a rectangle if you did that. You would walk down one street, take a turn, walk down the other street, take a turn, walk down the other street, and take a turn. Walk down that street. You've just really walked in a line. Now your line had turns in it, but still you're walking in a line. You're not covering the whole area of the block because you're really just measuring a line on perimeter. You'll have regular units like inches, meters, yada, yada, yada. But when you're looking at area, because we're covering with squares, we'll have square units like square inches, square meters. Now, surface area and volume, on the other hand, are ways to measure 3D shapes. You're going to notice that you have 2 formulas on each one of the lines. Like, for example, rectangular prism, we see the SA formula and we see the V formula. Well, guys, we're talking surface area and volume. You know what SA stands for? Surface area. Again, area is always a covering. But with surface area, I'm talking about covering the outside of a 3D shape. It's like the wrapping paper on your Christmas box. And you often see those little squares on the back of wrapping paper when you go to cut it out. Because even though it's a 3D shape, if I covered it, I'd be covering it with squares. And so once again, we're going to see square units. Volume, on the other hand, is a 3D measurement for a 3D shape. Volume is the space inside the box. One more thing to note down here. They have it in 2 places, super important. There's a symbol that gets used a lot in geometry. The symbol is called pi. Looks like this. You will see it in many of the formulas. Pi is not a variable, even though it looks like one. Variable means something can change. Pi is a constant. It's always the same number, but it's an ugly number that goes on and forever in its decimal form. So we choose to just write pi. But as far as the GED is concerned, they let you use a rounded version of pi. And if you forget what it is, it's 3.14. It is on the GED formula sheet in 2 places. And they use a wavy equal sign, meaning I've rounded. Pi is approximately equal to 3.14. Looking at that second section, the data, once again, it's just mean and median, which are ways of dealing with sets of numbers. So like if I go out into the real world and gather some data, I ask every person to grade how much they like my classes on a scale of 1 to 10. I could find the mean or average, and they could use either word of that data. I could say on average, people think my classes are about 3.5 on a scale from 1 to 10. Then I could go home and cry. And median there, the middlemost number. 2 ways of looking at sets of numbers. Last section is the algebra section, they say, and as I told you, it's really pretty random. The first 3 all have to do with slope and lines. We don't actually need this third formula. There's nothing that this third formula does for us that the first 2 can't do. We won't use that one either. Quadratic formula, that's there. And that one is used to solve for X. You say, Kate, why do we need a formula to solve for X? We just learned to solve for X 2 classes ago. It's a special case where you have an X that's squared and an X that's not squared. You could try our methods over and over again to try to isolate the variable, get the letter alone, and you wouldn't be able to do it without some additional tools. Well, this is one of the tools you could use to solve an equation like that. And then randomly, I don't know why they chose to stick it here, but the Pythagorean theorem is actually a geometry theorem. It relates the 3 sides of a right triangle, A, B, and C. So you can use it to find a missing side. And then how to find total distance, how to find total cost. Those are kind of real life situations that come up that involve rates, and they're all down there. And the GED does love the concept of rates and unit rates, so you're likely to have some word problems that involve those. Let's do some examples. Example 1 says, find the area of a square with a side length of 8 inches. First question I want you to ask yourself is, what are we looking for?
The area of a square.
Bingo. It's super important that I know the measurement here that we're looking for, and I know what shape we're talking about. Students stop there at what am I looking for all the time. And depending on what I know, the way that I get there might differ. So Mason, I got a great example. Imagine I call you and I say, how do I get to the store right now? Should I turn left or right? How are you going to tell me left or right? I could be anywhere in regards to the store. So know where you're going, but know where you're starting too. So what info do we have in this problem?
We know that there's a side length of 8 inches.
Okay. Remember how I told you that a formula relates variables with an S? We need something, an equation that relates the area of a square to its side length. Let's go see if we can find one. All right, Mason, here's the formula sheet we were talking about. Which section do you think that I should be in if I want to find a formula that relates the area of a square to its side length?
I would look on the first line.
Absolutely. That very first section we said was the area section, and we are looking for a square. We find the individual shape, and there is the formula that we want. A is equal to, do you know how to read that, by the way, Mason?
Area equals side length square.
Bingo. Let's go use that formula. So just like we did last class, when we started evaluating expressions, our first step was always to start with a known truth, an agreed upon thing. Last class, it was whatever expression they gave us. But this class, we're going to be looking at when it's that formula. And that's a mathematician's way of saying, we're going to start with something we all know to be true. We all know it to be true that if you want to find the area of any square out there in the whole wide world, you can take the side length and you can square it. Now, our next step is to go from this general rule that we all know to be true and to apply it to our case. We're not talking about all the squares in the whole world. We're talking about one particular square, and it's a square that we know something about. There's a known value. Mason, would you go looking through this example and see what we know?
We know the side length.
Absolutely. We know the side length. And so we need to put this thing we know into our formula in order to talk about our specific square. Now, I have 2 variables in my formula. I have an A and I have an S. Which letter do you think stands for side length?
S.
Absolutely. And so I'm going to replace the s with the known value. I'm going to write this down 8 squared, but I asked you to do something last class. I asked you to use a symbol to make sure that that square would work on the whole number. Now, it actually doesn't matter in this case, but it matters in a lot of cases. So we want to have good habits. I'm going to put this 8 in parentheses. Lovely. Now, you might say to me, Kate, why does it matter? We will see things that if you don't use a parentheses, you'll get a wrong answer. Great example is if you had a fractional side length. I could tell you that your side length was 2/3 inches. If you just put the square right here without using parentheses, you would only be squaring the 2. You don't want to square the 2. You want to square the entire side length. Now, another thing, I have a lot of students who just want to deal with the right-hand side of a formula. That is one of the worst mistakes you can make. You are screwing yourself over for later, more complicated problems. I need you to remember that a formula is an equation, not an expression. Do not lose the equal sign and do not lose the other variable. Now, notice I called that one an A. Why did I not substitute for A? Well, A stands for area, and area is the thing we don't know. They didn't give us any information about area. And when we don't know something in algebra, we use a letter to stand in its place. And now we are going to look for what I'm going to call our simplified solution. Do you see any operations that we can do?
There's an exponent.
Yeah, absolutely. We don't have to call it 8 squared. We can find out a simpler equivalent value. So I put 8 in. I'm going to put my parentheses because I have good habits, and I get 64. And again, I speak in complete math sentences, and that's why I say it's a solution. I get A is equal to 64. I've solved my mystery. Now, the only other thing that we need to worry about is the units. Area was needed to cover a shape, so we didn't use plain old inches. We used
Square inches.
Square inches or square meters or square yards. And so that's going to be abbreviated with the inches abbreviation, but a little 2 on it. And so I wanted to do that. So when you guys see something like that, whether it's in the problem or in the answer, you don't freak out thinking it's extra math to do. That happens to students a lot. No, this is just my mathematical abbreviation because I'm too lazy to spell out square inches. So now my answer is an equation. It's a complete math sentence. The area, A, is 64 square inches. You could say it in English, or you can say it in the language of math, like I did. Means the same thing, but I would argue math is superior because I used less symbols than you English majors. Let's look at another beginning level example here. So a rectangle has a length of 17 centimeters and a width of 15 centimeters. What is its perimeter? What are we looking for?
We are looking for perimeter.
Awesome. Perimeter of what?
Of a rectangle.
Beautiful. What do we know?
We do know what the length of the rectangle and the width.
What is the length?
17 centimeters.
Awesome. And you said we know the width as well?
Yeah, 15 centimeters.
Gorgeous. So what we need now is a formula that relates those 3 variables, the perimeter to the length and the width. All right, Mason, looking at that formula sheet, I am in the world of geometry, so I'm expecting to be somewhere in the top half. Which one of those 3 sections do you think I should be in here?
The second section.
Absolutely. And what shape?
Of a rectangle.
Of a rectangle. Take a look at this formula, Mason. What are the 3 variables you see?
PLW.
Absolutely. Perimeter, length, width. We're relating the thing we're looking for and the things that we have. So here is my formula, the thing that's always true, but now I need to apply it to my specific situation by plugging in any known values. Can you do the substitution step for me?
So we do know the length and the width.
Beautiful. So I'll start with the length. I will trade it out for what value?
17 with parentheses.
Absolutely. How come you chose to use parentheses this time? There's no exponent.
They're still multiplying.
Yeah, there's still multiplication. Parentheses are used for a lot of things. They're used for grouping. That's what we were doing with the exponent, but they're also used to signal that two numbers are multiplying. What else?
We know that the width is 15, and you want that also with parentheses.
I agree. Again, another common issue for students is losing symbols from one line to the next. So let's make sure we've replaced our L and our W, but we haven't changed out anything else. So everything else we saw from above, we should still see. What do I still need in this equation?
The 2 next to the 15. You'll want to drop down the plus sign.
Good. Don't lose any operations.
And we're still figuring out perimeter.
Good. I still want to see P equals. So I would like our simplified solution. This is a complicated way to talk about the perimeter. It's true, that is the perimeter of my rectangle, but I could make that a whole lot simpler by performing the operations, by doing the addition and multiplication. Take a look at that expression on the right-hand side, Mason. Do you see any variables, any letters?
No.
No, once there's no letters left, our calculator can handle it. I'll do 2 times 17 exactly the way I see it, plus 2 times 15. And that entire right-hand side simplifies to 64. The last one was 64. Apparently 64 is the magic number today. And I'm going to continue to speak in complete math sentences. That is my simplified solution. Now I need a unit. This time we're not area. This time we're perimeter. We're just going a line around. So we said we'd use plain old units. So it's plain old centimeters. So one way to read this is P is equal to 64 centimeters. But another way to read this is to talk about what that variable means. The perimeter is 64, and I'm abbreviating for centimeters. Don't freak out with fractions. Soon as I put this on the slide, I saw Mason's eyebrows raise. And I know that some of you turned off the video so that you could go vomit. But remember, we're going to do the computations in our calculator. The hard part of fractions was not writing them down, which is all we're going to have to do. It was adding and subtracting them, which we're going to let our calculator do. So go ahead and read this problem for me and do the same 2 things for me, Mason. I want to know what I'm looking for, and I want to know what's known.
So we know that the triangle has the side lengths of 18 and a half, 16 and 3/4, and 11 and 1/4 inches.
Beautiful.
We're looking for the perimeter of a triangle.
Beautiful. Let's go find the formula that relates perimeter of a triangle to its side length. Now, even though this one is not a hard formula at all, looks a little scary, but it's not nearly so scary as it looks. Those subscripts, those numbers down at the bottom, that's not an operation. It's not math to do to the side lengths. All it signifies is first, second, or third. So S1 means the first side. S2 means the second side. S3 means the third side. Super simple formula when you're looking at it that way. It says to find the perimeter of a triangle, add together the first, second, and third side. Here's my formula. This is my known truth. Help me do the substitution here, Mason.
Well, first we want to put the perimeter.
Absolutely. We don't know the perimeter. We'll have that P stand in for the unknown.
And then we do know the side length.
Question I get a lot is, but which one is S1? It's not like it matters what order you add in, so don't get all caught up in details that don't matter. Which one would you like to call side 1?
11 and a quarter.
Sure. Then what?
You drop the operation addition.
Absolutely. I'm not going to lose my operation.
Then you'll want to add in 16 and 3/4.
Sure. And then what?
We got to drop the second operation.
Good. I'm not going to lose any operations.
The last one being 18 and 1/2.
Lovely. So there's my perimeter. Once it's all numbers, our calculator can handle. Mason, do you remember how to put a mixed number into the calculator? When I say a mixed number, I'm talking about a number that has both a whole number portion, that's a big ol' 11, and a fraction.
First, you put in the whole number.
Yes, sure. I can start with that, 11.
And then hit that green button on the top where it says second.
A mixed number is here. U n over d, it's in green, so I need the green button. Beautiful, Mason. And then I can hit that n over d button. Make sure you get out of that fraction before you hit plus. And again, second and the n over d button to get a mixed number. I'll put in 16, arrow in to do 3/4, arrow out of the fraction before I add second UN over D, 18. I get a kind of weird answer. It is a true answer, but it's kind of weird right now. So this says P equals 93/2. Now this is a correct answer. It's just not a normal answer. If I'm in the world of geometry and I ask you the perimeter of a triangle and you say 93/2, it's like, wait, how big is that? That's 93/2 is kind of hard to think about. And so we usually prefer numbers like this, where the top is way bigger than the bottom in the form of a mixed number. N over D, pure fraction, converting, see those little arrows, to U N over D, to a mixed number. So again, it's in green. I'll hit the second button, and then I can hit that convert, and it'll automatically convert my answer to 46.5. 46.5 what?
Plain old inches.
Plain old inches, its perimeter. That is my simplified, because I performed the operations, solutions, because I solved the mystery of what P is equal to. It says find the area of the shape. So what are they asking me to do or to find?
To find the area.
But we don't just need to know the measurement. We need to know the measurement of what shape. So that's the tricky part here.
A trapezoid?
It's similar to a trapezoid. A trapezoid has one set of parallel sides running in the same direction, but the other ones can be all crazy. This one has two sets of parallel sides. The top ones are running in the same direction, but so are the side ones. It's kind of like your rectangle fell over, like you didn't know how to build your bookcase. That's me. I don't build good bookcases. Mine are not rectangular. They are parallelograms. That is what that's called. We are looking for the area of a parallelogram. And then this little right angle. When you see that right angle in a shape with the little dotted line on the inside, that's a clue that we're looking at the height and the base. This little dotted line that drops down from a corner at a right angle is known as the height. And this side that forms the right angle, so I think of it as looking for the T, is the base. Wonderful. So we need a formula that relates the area of a parallelogram to its height and its base. Where am I going to look?
The first portion.
Absolutely. It's in the area category.
And it's on the third one. Yeah.
There you go. Parallelogram. And look, super simple formula. So it says area equals BH, or to find the area, multiply together the base and the height. Please help me do my substitution step, Mason.
I would first make sure to put down the area and equal.
Absolutely. Area is the mystery I'm solving. I want to know what the area is.
The base would be 8.5.
Beautiful. I'll replace B with 8.5.
They need to be with parentheses.
Brilliant. Sure. I can enclose 8.5 in parentheses.
And we also know the height, 9.2.
And I think I'll put that one in parentheses as well. It's really only necessary for one of them to be in parentheses. That's enough. But since it's usually at least the second one, I'll do that as well to not be confusing. Cool. I did my substitution. What now, Mason?
Now we got to follow the operation that's shown.
Brilliant. Those are just numbers. We can perform that operation. And I get 78 and 2/10. Now what?
Put down the area because we just solved it.
Beautiful. So A is equal to 78.2. And what is my unit?
Millimeters square.
Beautiful. It's an area, so it's going to be measured in square units. Okay, Mason, we're going to move on up to an experience level practice. Only one that really makes this experience is that it's a more challenging shape, but hey, we already talked about it. And I was a jerk. I gave you more information than you need. Ha! What are we looking for?
The area of the shape.
Any idea what that shape is called?
A trapezoid.
Absolutely. We just talked about that. It has one set of parallel sides known as the bases, but the other sides are not parallel. They're going any which wonky way. So, and we actually know a lot of stuff this time. Let's go get the formula and then we can talk about which things we need. Okay, Mason, help me find the formula I need.
It's under the category of area, and it's the second one from the bottom.
Beautiful. And you can see why I wanted to do it with you. Looks really gross. It's not going to be that bad, but we got to not freak out when we see it. So the area of a trapezoid is equal to 1/2 of the height times the quantity of base 1 plus base 2. Now we can see what variables are related here. So obviously we have that A for area, but we have an H and a B1 and B2. Let's start with the B1 and B2, because I think based on what we've already said about this trapezoid here, you got a pretty good guess about what B1, the first B, and B2, the second B, represent. What do you think?
B1 would be 15.
Yeah, absolutely. B stands for bases. It's those two parallel sides. Now, we have one other letter we need to know about, H. Do you remember when we talked about a triangle, we said base was always perpendicular to what?
Oh, to the height.
Absolutely. That's the height of that trapezoid. This formula relates area to base and height, meaning I don't need any of the other numbers. So these were just distractions I was trying to throw at you because I'm a jerk. Help me do my substitution.
Put down the area in equals. Then I would add in the half parenthesis.
Good. The 1/2 and the H are shoved together. They are multiplying. I will do a small parentheses just to put my height in it. What did you say my height was?
19.
19. Now, here's a common error for students. They start making short parentheses, but I need you to see that the original expression had a nice long parentheses with B1 and B2 in it. Just like we don't lose operations, please don't lose groupings. I want to see a nice long parentheses for your B1 and B2 to be adding together in there. Now what?
15. Never forget your addition. And then the second base being 32.
All righty. That right-hand side is just plain old arithmetic, ugly arithmetic, but our calculator can handle the computation. So I need a regular plain old fraction, so I'll just use n over d, 1/2, and I arrow out of the fraction before I open up parentheses for 19. Don't forget to close that parentheses before you open up parentheses for that base group. So 15 plus 32, the sum of the bases. Enter. And oh my gosh, I got a super weird looking number that makes me want to puke. What can I do?
I would change that fraction into a mixed number.
Beautiful. It's not wrong. It's just weird. So let's convert it into a mixed number. Again, we will use our n over d to un over d key. And we can see that's the same as 446 and a half. 446 and a half what?
Millimeters squared.
Beautiful. Square millimeters. Another experienced example, find the surface area to the nearest tenth of a square centimeter of a cylinder with a radius of 2.5 centimeters and a height of 6 centimeters. First of all, Mason, what are we looking for?
Surface area of a cylinder.
Beautiful. So what a cylinder looks like is it's got two circular bases that look just the same, and then it goes up and down like a drinking glass. And then what do I know?
We know that the radius is 2.5 and we have the height of 6.
Beautiful. We know what we're looking for, surface area of a cylinder. We know what we have. We have a radius and height. So we need a formula that relates those things. So remember that I said that a cylinder was a 3D solid? We've only been working in the area and perimeter because we've been working in those flat shapes. So now let's scroll down to that third section. That's where we find the 3D solids. Now we're going to notice there's two formulas. Which one shall I use?
Surface area.
Beautiful, the essay. There's the ugly thing I need. So to find the surface area of a cylinder, take 2 times that little symbol again we said was called pi, times the radius, times the height, plus 2 times pi times the radius squared. Looks gross, but it's not actually as bad as it looks. Start with my formula, no changes made. And now I will start substituting in any known values. Help me substitute into this.
SA equal 2 open and close parentheses.
Beautiful. Mason's going to replace pi, but pi is not a variable. It's not in the problem. We did have it on our formula sheet. We circled it even. Mason, do you remember what pi was approximately equal to?
3.14. Open another parenthesis, and we know the radius being 2.5.
Beautiful. Now I'm not losing anything. That was the radius, but I still have an H. H for?
6.
Beautiful, the height. And now this is getting a little wide, so make sure you go back. I still have a plus. I still have a 2. And now there's pi again. Let's plug them in. And there's radius again. Let's plug that in. But notice that radius is being squared. So close parentheses and get that square on the outside so that you have every single symbol and operation from above. There's no variables left. Hit up your calculator. 2 times 3.14 times 2.5 times 6 plus 2 times 3.14, close parentheses, open parentheses, 2.5, close parentheses, before I square it, enter. 133.45, my simplified solution. Alrighty, what's my unit? Areas, area. What did I measure area in on flat shapes?
Squared.
Squares. Surface area on 3D shapes, we're still covering the outside. It's still a flat measurement, even though it's a 3D shape. And so it's still measured in squares. So square centimeters in this case. Okay, $14,000 is invested in an account that earns 2.2% annual simple interest. And then we have 2 questions here. So let's just start with the first thing. How much interest will the account accrue after 4.5 years? What am I looking for? I'm looking for interest. And my problem also specifies that it's simple interest. Simple interest is the only kind of interest on the GED. But if you go on to college, you'll see that there's other types of interest. And then what do I know?
There's an investment.
An investment. Your original investment is known as your principal. So my principal is $14,000. What else do I know?
The annual earning is 2.2%.
Beautiful. Glad you tacked on that percent. 2.2 without a percent symbol is different than 2.2%. This is the interest rate. When you write it down, don't just write 2.2, write 2.2%. And then there's one other thing that we know.
4.5 years.
Beautiful. We know the time that our investment is going to sit in this account earning interest. Interest has nothing to do with the shape. It's also not the mean and median data analysis. So go down to the bottom with those random formulas. Do you see the formula that we need?
I equals PRT.
Beautiful. Multiply together the principal, the rate, and the time. Okay, let's do our substitution step.
First, I would put the I equals. We do know the principal. I would first add the parentheses with the principal of 14,000. Another set of parentheses with 2.2%.
Good. Thank you for keeping the percent sign. If you drop the percent sign, you're not giving yourself a portion, 2.2%. You're doubling your money every year. You guys wish it worked that way. You're doing 2.2 times. I need 2.2%. Then what?
Parentheses 4.5.
And I'm earning 2.2% interest per year. And this is 4.5 years. So I am good to go. All right, now what, Mason?
Well, we do have everything on there.
Exactly. Calculator time. Open up parentheses, 14,000. You do not need the comma. Close parentheses. Open up parentheses, 2.2. Don't forget the percent. If you forget the percent, you're not doing the math you think you are. Okay, so I'll hit the second button, the percent button, close it. And then I'm going to times that by, I need a mixed number. So I'll use UN over D, 4.5. Arrow out, close my parentheses, and bingo. My interest is going to be $1,386. Let's take a look at the second question. What will the total balance be after the interest is accrued?
Would it be $15,386?
Yes, Mason, you jumped straight to the answer. How'd you get that number?
I took our beginning amount. And then I did some addition with the interest.
So absolutely, I agree with Mason that if I added 14,000 and 1,386, I would end up with $15,386. So let's look at example 8. Find the volume to the nearest cubic inch of a sphere with a diameter of 19 centimeters. Mason, what am I looking for?
The volume of a sphere.
And what do I know?
The diameter of 19 centimeters.
Do you know what a sphere looks like?
Isn't that like the 3D version of a circle?
What a great way to put it. It's basically a ball. Okay, Mason, where do you think I will find that formula then?
I would first look in the surface area and the volume part.
What
And
shape are we looking for?
a sphere.
And there's two formulas. Which one should I use?
I know the question was asking for volume, so I'd go with the one on the right.
Beautiful. Now that I have my formula, can you please help me substitute in?
Volume equals 4 over 3, parentheses, and we know that pi is 3.14.
Yeah, 3.14, close enough. Approximation.
We do know the
Mason just got stumped. This is where you should get stumped too. Please do not be the foolish student who's just like, I'll plug in whatever random number I know. That R stands for something. This formula relates the volume to the radius, and they did not tell us the radius. We need to know something about geometry. So I love how Mason said a sphere is like a 3D circle, because the first time we learn about radius and diameter, it's on a circle. So let's draw that. Diameter and radius are related, but they're not the exact same thing. So when you look at the center of a circle, a diameter goes all the way across, and a radius just goes halfway across. Very popular GED math trick. Instead of giving you what you need the radius. They give you something else, the diameter, and they're expecting you to have the mathematical reasoning to go take what they gave you and turn it into what you need. The GED is not your mama. They're not trying to meet your needs. They're trying to test your mathematical reasoning. All right, so any thoughts? If I know this diameter, how could I find the radius?
since a diameter is across a circle, radius is only just half of it. What comes to my mind is division.
Yeah. What am I going to divide it by?
2?
Absolutely. One way to think about halving something, yes, I could times by 1/2, but Mason's right. That's the exact same thing as dividing it into two equal pieces. So great way to go about it. 19 divided into two equal parts does give me 9.5. My radius is 9.5, not 19. And this is the one I want you to be careful of. Okay, you got an extra step to turn diameter into radius. Now what?
Well, we still have our cubed.
Oh my gosh, I got so excited about diameter to radius. I tried to be a bad secretary. Thank you for keeping me on track. Don't forget any operations. Good job, Mason. Way to pay attention. Now what?
I noticed that there's no letters on the right-hand side, so I would go ahead and start plugging into our calculator.
Beautiful. We can simplify the expression on the right-hand side. So I'll pull up a fraction bar with n over d, type in that 4/3. Arrow out of that, open up for 3.14, close parentheses, open up for 9.5, my radius, not my diameter. And to cube it, you use the little caret button that's above x squared. Then you can type the exponent 3. There we go. Do you see what I still need to do to finish this example up?
Oh, I see it. To the nearest cubic inch.
There's some rounding language. To the nearest cubic inch. I didn't name a place, did I? It's not tenths or hundred. When I just say cubic inch, where am I going to stop?
I want to say the first digit after the decimal.
Bingo. That's the idea there. It's at the decimal. When I want the nearest cubic inch, I'm looking for whole cubic inches. I can get rid of pieces and parts. But as Mason just pointed out, and before you get rid of pieces and parts, examine that number you're about to throw away. What, am I closer to 3,589, or am I actually closer to the next number, 3,590? Am I halfway through my digits yet? I am. So this puts me more than halfway to 3,590. And so I'm going to round up, and I rounded to the nearest cubic inch. So this time with volume, you'll see that inch with a little floating 3. I'm measuring in cubic units. Example 9. How far can a plane flying at a speed of 650 miles per hour travel in 1 hour and 40 minutes? Mason, what am I looking for?
I want to say the distance.
Brilliant. Mason saw this phrase, how far? He said that must be distance. Okay, what do I know?
Well, we do know the speed, 650 miles
Miles
per
hour. Beautiful. I don't want to forget that per, because that per is going to be a big clue about what that number is. Next thing.
We know the time, 1 hour and 40 minutes.
Good. All right, let's go find our formula. Okay, Mason, boss me around. Where do you think I should go?
I would go to the bottom section.
It's a random formula. Hit up the bottom. Okay, what you want?
The distance formula.
Good. Distance equals rate times time. Help me substitute into this sucker.
Do you want to put distance equals?
We don't even know what that R stands for. But look at the information you have known. You know the speed and you know the time. Remember I said I didn't want you to forget the per? Per is a big clue about what this thing is. Anytime you have a blank per blank, we can refer to that as what?
Rate?
Brilliant. Speed is one way to refer to a speed as a rate. It's a rate of how fast you're moving, but it's a rate. So we will plug in 650. How about T? What's T?
1 hour and 40 minutes.
Good. But we have a problem. We have mixed units. I don't just have hours or just have minutes. I have hours and minutes. And I should only use one. I should use whichever one is in the rate. So go back to the rate. The rate was 650 what?
Miles per hour?
Per hour. I need the time in hours. If it was miles per minute, I would need minutes. If I know how many miles per hour that I go, then I'm going to go that many miles the first hour, and that many miles the second hour, and that many miles the third hour. So I need to make sure those units match. Only part of my number is in hours. The 40 is not in hours, it's in minutes. But that's why fractions exist, you guys. I know you guys are so super scared of fractions, but fractions are not that bad. We can use them when we're lazy. We don't have a full hour. We have 40 minutes out of, Mason, what would a full hour be?
60 minutes.
60. And now this whole thing's in hours instead of being in hours and minutes. We have a full hour and a part of an hour. Beautiful. Let's type it into our calculator. 650 times the quantity. I need a mixed number. And so I will hit second U N over D, and I'll put in that 1 hour and 40 out of 60, a part of an hour. Whoa, look what I did. I put the parentheses inside. Don't forget to arrow out before you do the parentheses. And you can see it gave us an ugly decimal, and there's no clue here about what to round it to. If this happened on the GED and there were no rounding directions, it would simply be multiple choice. So 1,083 what? Well, we were looking for distance, and this was miles per hour. So again, we're going to see those matching units with the rate. The distance, 1,083, is going to be in miles. So it says find the slope of the line containing the points 4, -5, and -2, -1. Mason, what am I looking for?
A slope of a line.
Beautiful. And Mason, what do I know?
The points for...
See the comma in between? It's not 4 - 5. It's two separate numbers. 4, -5. Beautiful.
And -2 and -1.
Good. Okay, Mason, where do you think I should go on the formula sheet?
Straight down to the bottom.
Straight down to the random bottom. It's like random. Okay. Now we got to find the right formula. I will remind you that we said that there was a lot up at the beginning of point and lines, and we were only going to use the first two because that's really all we need. The other ones are nice, but not necessary. Which one do you think I need? What was I told to find? What did we say we were looking for?
Slope of a line.
So which one of these formulas do I need?
The first one on the top.
The first one. It says slope of a line. Yeah, exactly. That one directly finds slope of a line. Now, the other one has to do with slope, and we will sometimes use it with slope, but it also has to do with what we've been given. Look at that. A couple of Y values, a couple of X values. And we have 2 points, right? What are points? X's and Y's. But one weird thing that you need to know is that we don't use the letter S for slope like you'd expect. We said this was the slope of a line formula. And Mason, look at what it's solved for. What letter is alone?
The M.
Absolutely. The M is all by itself. It's solved for M. And indeed, M is the letter we use for slope of a line. And then these things in here, remember, we see that subscript, it just means first and second. So I'm saying take the second Y and subtract the first Y. Take the second X and subtract the first X. And in a point, the first value is an X and the second value is a Y. So that's an XY. But we have 2 points. So that's also an XY. And that's that idea of why we need a first and a second. So this is the X on the first point and the Y on the first point. And this is the X on the second point and the Y on the second point. Now let's substitute in what we know. So we are finding the slope, and it's going to be equal to, don't forget that nice long fraction bar. And now we want to take the second y and subtract the first y. Mason, what's the second y?
-1.
Beautiful. And from that, I need to subtract, put a minus because there's a minus in the formula, and I need to subtract the first y. What's the first y?
-5.
-5. I need to subtract -5. Really common student error is to drop a negative sign, but there was a minus in the formula and there's that negative in the number. And so you need both of them. So it's -1 minus -5. And a lot of mathematicians will put a parentheses around that -5 there. And that one, again, we use parentheses for a lot of things. It's just visually separating the minus and the negative there so you don't get confused. Then can you help me plug into the denominator, the bottom of this fraction?
-2.
Good. Be consistent about what you're calling the second point and the first point.
-.
Good. Subtract in the formula.
4.
Good. This time it is a +4, and so we won't see the extra minus sign. So I'll start with the fraction bar when I have this long, ugly, nasty looking fraction with lots of things inside of the top and inside of the bottom. And I'll type -1 minus, open up my parentheses to do -5. Notice I use a different key for negative than I do for minus. So important to be able to read this sucker. When I arrow down and do -2 minus 4, press enter. And it does a reduced fraction for you, so you don't have to know a ton about simplifying fractions. So the slope is -2/3. So imagine some stairs and they go 2 feet down, 3 feet over, 2 feet down, 3 feet over, and your line is like a board laying over the top of those stairs. Find the volume of a pyramid with a height of 23 inches and a square base with a side length of 15 inches. What am I looking for?
The volume of a pyramid.
Good. And what do I know?
The height being 23 inches and a square base with the side length of 15.
He's like, that's not the information I was expecting. So height of 23 inches. And then the base, they give us some interesting information. They tell us it's a square with side length of 15. So first of all, I'll just give you a visual. Like pyramid looks like this going up into a point with the flat sides, like you can picture the pyramid in Egypt. When I say that it has a square base, I'm talking about the bottom of it. So imagine picking up this pyramid and looking at the bottom. If I were to do that, that bottom would be a square.
Okay.
So this time, instead of a base being a line, like it was on our flat shapes, a base is a shape. We could look at the base if we imagine turning that pyramid upside down and just looking at the bottom. And the bottom would be a 15 by 15 inch square. Let's go find our formula. Okay, Mason, where do you think I need to be?
Surface area and volume section.
Brilliant. Third section down. And which one would you like?
The pyramid.
Pyramid. Which formula?
Volume.
Good. Now, I want you to notice something. Notice that this time, the B here is capital.
Yep.
We've done formulas before up in an area where we had B's, but they were lowercase b's. It's not just a typo. I'm not just being careless and sometimes using a capital and sometimes using a lowercase. It's important you pay attention to capitalization in math because we will use them to throw you a signal. That capital B is telling you something else. So when we looked at the base before, we were talking about lines on these 2D shapes. But just like when I drew my picture, when I'm talking about the base now, I'm talking about that square. It's a full shape, not just a line. So that capital B, they tell you down here, it stands for area of the base shape. Mark that on your formula sheet because it's a sign that we have to do a 2-step formula. In order to find the volume, we need to know the area of the base. Mason, what did we say our base shape was on this pyramid? When we turned it upside down, what was the shape?
Oh, a square.
A square. So in order to do this, we don't need just this formula, V equals 1/3 BH. We also need the area of the square formula. And we see an area of a square formula is A is equal to S squared. That capital B is a signal that I have a 2-step problem. Okay, so yes, your volume is equal to 1/3 of the area of the base shape, capital B, times the height of the pyramid. But this capital B here is a signal that I have a two-step. I have to find the B, the area of the base shape. So I will do that as my first step. So we said the base shape was a square. So we would use the area of a square formula. So A is equal to S squared. Now that's a little confusing. I call it A, but I also call it B. So woo, I'm getting a little tricky here. But either way, whether I call it A for area of a square or I call it B for the area of the base shape, I'm talking about the same thing. Okay, so let's plug in what we know. Now, when we're looking at the area, we're just looking at the base. So ignore any other information. Think about that square base. So the area of the square base is going to be equal to the side length of the square base. What's the side length of the square base?
15.
15. And so we'll find that our area here is equal to 225. That's the piece of information I needed. I needed to know the area of my base shape to find the volume. So let's do it. Let's say the volume is equal to 1/3. Now, that was why I needed B, right? B was my area of my base shape. So I'm going to take this 225 area of my base shape and plug it in. Tricky, tricky, tricky. And then H, that H, we're not talking about the base shape now. We're talking about the height of the pyramid itself. What's the height of my pyramid?
23 inches.
23 inches. There's all numbers on the right-hand side, so I can just go ahead and simplify this. I'm going to put in my fraction type 1/3, arrow out, open a parentheses, 225, close parentheses, open a parentheses again, 23, close parentheses, press enter, and I get 1,725. And 1,725 what? Well, this was volume I was finding, so it will be measured in cubic units. They were inches, so I'll see cubic inches. All right, nice job. Congratulations, you did some really challenging work with me today. Now you need to go practice. It's always easy when the math teacher does it. Make sure that you complete at least one level of practice in order to have a memory of what we were doing on test taking day. Happy learning.